here is a quick review of 7 questions from a recent test that I had given to college physics students, which is actually the trig-based study of physics. So let's go into these questions. The first question talks about a person looking at the top of a flagpole from some distance away. And there is an angle of 25 degrees. So there is the flagpole. So you can see that this is the flagpole right there. And the person is standing right here. That's the feet of the person. That's the eye. So at the eye, the angle made is given. This distance is given as 35 meters. And we are asked to find the height of the flagpole. So you can see the right angle triangle already set up there. And it's basically using trig to find this distance and then add this. So this is given as 1.7 meter, which is the distance of his eye from the feet. So that's it. So it's about trig. And so let's say AB is the flagpole. And then you have that angle given as 25 degrees. So if you look at the triangle BEC, look at the triangle BEC. And from the angle given here, we know this is the opposite side of the angle. This is the adjacent side. So tan theta is opposite by adjacent. That's why tan 25 or tan theta would be BC, is the opposite side of the angle, divided by EC. Okay? And then tan 25 is equal to BC by 35 meter, because EC is how far away the person is. That's given as 35. So when you rearrange that or do the math, you get BC is equal to 35 times tan 25. And when we put that into the calculator, we get that as 16.32 meter. So that is BC. But we got to add AC. And AC is given as 1.7 meter. So when you add them, you get 16.32 plus 1.7 meter, which happens to be 18.0 meters. So that's the height of the flagpole. So it's basically using trig here in this right angle triangle. In this problem, you have an object that is starting from rest. So the initial velocity is 0 meter per second. We have to find its final velocity. So that is v sub f, which we are looking for. And then its acceleration is given. The acceleration is 10.8 meter per second squared. And you also have the displacement. So it goes from 0 to something within a distance of 400 meters. So when you have all these terms, you have to be able to recognize the kinematic equation. And that comes by practice. Chiefly here, you have to look for the equation that does not have any mention of time, because there is no talk of time anywhere here. And so you know that the equation would be Vf squared is equal to V naught squared plus 2a delta x. After that, it's math. And V naught squared is 0, so I've not written it. So you have 2 times 10.8 times 400. When you do the calculation for that, you get 8640, and then you have to take the square root of that. When you take the square root of that quantity, you get the final velocity. 93.0 meter per second. Is this answer practically okay? Yes, it is. Because it's talking about something moving very fast, something that's accelerating really fast. So that answer is okay. That brings us to the next problem. So in this problem, you have two vectors. There is a vector A, which is making an angle. There, you see the vector A. That angle is to the north of east. North of east. So you start from east and go north. North of east. But the other vector B is actually making an angle with the south. You can see, so if you just started from the south, it would go this way to the west. Okay? So it's making an angle of something with the west. So the magnitude of the vectors are given. So the angle for the first one is 30 degrees. Second one is also 30 degrees. And the magnitudes of A is 6 meters and B is 4 meters. And we are asked to find the resultant or the sum of these two vectors. Yes, each one is given, one is 6, the other is 4, but the sum is not 10. You can't do that with vectors. So to find the sum, we have to break A into its x and y as shown in the diagram. You see the x component of A, this is the y component of A. We will do the same with B. You will find that is the x, and see the x component of B, and then you see the y component of B. So remember, these two are negative because it's going to the left and this is going down. So those two are negative. While if you look at the components of A, this is positive, this is also positive. It's to the right and up. Okay, and then we use trig to find those components individually. Let me show you how that is done. So let me label them as AX, AY, BX, and BY. And then we'll talk about this triangle first. So from that triangle, AX by A is cosine of 30. Because AX is the adjacent side divided by the hypotenuse. So you have to know your SOHCAHTOA. C-A-H stands for cosine is adjacent over hypotenuse. You have to know that. So when you do that and then calculate AX, you get it as AX is A cosine 30. A is given as 6.0. And so you multiply 6.0 with cosine 30. And that would give you the x component as 5.2 meters. Now for the y component, since it's the opposite side, you see it's the opposite side, it's going to be sine. So it'll be AY is A sine 30, which is 6.0 sine 30, which comes out to be 3.0 meter. We'll do the same with vector B. When you come to vector B, got to be careful because this is the opposite side. See, because the angle is here and this is the opposite side. And the opposite is always sine. So, S-O-H. Sine is opposite by hypotenuse. So we cannot memorize. We have to know the rules. So that's why BX becomes B sine 30. And that is 4.0 sine 30, which is 2.0 meters. And BY, because this is the adjacent side, it's going to be cosine. BY is B cosine 30. That would be 4.0 cosine 30. Okay, let's see how much that happens to be. That is 3.5 meter. And both are negative. Just like I reminded you before, both of these are negative. Next, we have to add the x components together. So you have AX and you have BX. Add them, so you will get the total x. So that is AX plus BX. And what was AX? It was 5.2 plus BX was negative 2.0. So you add that, that will give you 3.2 meter. Now for the y, do the same. AY plus BY. And the AY is 3.0. plus by is negative 3.5, both in meters, so you get it as negative 0.5 meters. So now we got the total x and the total y. Let me show you what that is, and now we got to do the final step. So here we go. That's your total x and total y. So that's your x, total x. This is your total y. We could have drawn it here, or we could draw it here. Same thing. And then if you draw it here, then you understand you have another right angle triangle, and all we got to do is find the hypotenuse, which we're going to do now. So that's 3.2. This is 0.5. Actually negative, that's why I put it down. Okay. So AC squared, is AB squared plus BC squared. That's what we're going to do. And then AB is 3.2, so that's 3.2 squared plus BC is negative 0.5. So if you've written negative 0.5, it will not make any difference because the square of a negative quantity is a positive quantity. Okay, just remember. So that is 10.49. Remember, you got to take the square root of that, and square root of 10.49 will give us 3.2 meters. So that is the total vector. But we also need to find the angle theta, because this is our total. AC is our total. We got to find out how much angle it makes with the x-axis. So for that, use tan theta. So tan theta would be 0.5 divided by 3.2, because tan is opposite by adjacent. Remember the TOA part of SOHCAHTOA, T-O-A. Tan is opposite by adjacent. So when you do that, you get 0.5 by 3.2, which is 8.88 degrees. Of course, you have to take the arctan or the inverse. So when you divide 0.5 by 3.2, you do not get 8.88. That is tan theta. Now, whatever number you got to take the inverse of that in your calculator. That's when we get 8.88 degrees. And isn't the angle south of east? Yeah, that's the east, and it's making that angle to the south. From the east to the south. That's why it's 8.88 degrees south of east. So in this question, you have an object that is actually thrown down. It's not dropped. It is thrown down at actually at 20 meters per second, but because it's down, we'll have to take it as negative 20 meters per second. Very important. So that's the initial velocity. So VO is negative 20 meters per second. I'm going to put the negative soon. And the time is what is given again, 3.0 seconds. And we have to find the height. We have to find the displacement. The acceleration due to gravity is negative 9.8 meters per second squared. And when you write all these terms, you should know the kinematic equation. I think it's the most useful one, which is delta y is V naught t plus 1/2 at squared. Okay, so that's the equation. And, it's actually negative 20 times 3 plus 1/2 times negative 9.8 times 3 squared. Now, why is it negative 20? Because the initial velocity is downwards. I'm going to put that now. So 20 times 3 is 60, but when I put the negative, it'll become, all right, there you go, negative 60, negative 44.1. That gives negative 104.1 meter. So it actually moved down. That's why we got a negative number. But when you're asked for the height of something, don't give it as negative. Just say it's 104.1 meter. Well, in this question, we have an object that is actually projected horizontally from the top of a building, or from the top of something. So it's important to notice that it's projected horizontally. So it has an initial velocity, but it does not have an initial vertical velocity, because when you project it, it's along the x. So we're going to consider only the y quantities first, and the initial y velocity is 0. That's very important. So there you go. So that's the diagram. It's projected horizontally from A, and it hits the point C. So it does have a velocity, but that's along the x-axis, which is what we have to find ultimately. Right, we have to find that. And let the height of that from where it's dropped be 200 meters, and let's assume that it falls 50 meters away. So those two are given. So like I said, we have to separate the x and the y. So right now we're going to talk about the y quantities. What is the initial y velocity? 0. So I'll go VOY is 0 meter per second. And we know acceleration is negative 9.8 meter per second squared along the y-axis. We're given delta y. It's negative because it's going down. So it's negative 200 meter. And then we could find the time using the same equation as in the last problem, which is delta y is v naught t plus 1/2 at squared. So substitute into that carefully. Negative 200 is equal to, and that whole term is going to become 0 there, so that's why I've not written it. And then this is 1/2 times negative 9.8 times t squared. And 1/2 times negative 9.8 is negative 4.9. And then you get t squared as negative 200 by negative 4.9. Now be careful there where you have to divide. Be careful with the algebra. You would get this as 40.8, but you have to take the square root to get t. And that will give you square root of 40.8, and that will give 6.38 seconds. So once you get the time that it takes to hit the ground, now we can go think about the x quantities. What do we know about the x velocity? That it never changes, because gravity does not act on the x. No way. So it's a constant. The x velocity is a constant. And because the x velocity is a constant, we can just multiply that velocity with the time to give the x distance, which is what I'm doing now. And remember, that equation only works on the x-axis. So delta x is VOX multiplied by time. Now this is the same VO that I've called VOX here. So don't be confused on that. So 50 meters is what it moved on the x-axis, and that should be the velocity times 6.38. So we get the velocity as 50 divided by 6.38, which gives us 7.83 meter per second. That's how you do it. So take a few minutes to look at how this has been done and practice a few problems like this. So let's move to the next one. All right, what do we have here? In this problem, let's assume that the initial velocity is 98 meter per second, and here the object is thrown straight up. Straight up. And the question is, how long will it take to come back to the point from which it was thrown? So if you were throwing it from the ground at 98 meter per second, definitely it goes way up and then returns to the ground. So when it comes back to the exact position from which it was thrown, the displacement is 0. That is the important point in this question. Displacement is 0 because it's landed back at exactly the same point it started out. So now we know the initial velocity. We're looking for the time, and delta y is 0. And acceleration is, of course, negative 9.8 meter per second squared. That was just a representation of it returning to the point. Same equation. I think we're using it the third time now. And then delta y is 0. This is 98 times t is unknown, so we will leave it as t plus 1/2 times negative 9.8 times, again, t squared is unknown. Okay? So let's simplify this. This becomes negative 4.9 because it's negative 9.8 by 2. And then, if you do the math carefully, it will be 4.9 t squared is equal to 98t. That's adding 4.9 t squared to both sides, which I've not shown. But that's what you may have to do. And then I'm dividing both sides by 4.9t. So the t is cancelled there, the square on the t here, the 4.9 is gone, leaving us with t is 98 by 4.9, and that's going to give us 20 seconds. So that's how we do that problem. I mean, that's a long time because we threw it up at a great velocity of 98 meters per second, so it went way up and came back down. All right. So here is the last question for the day. So we have the initial velocity as 0 meters per second because it simply dropped. The displacement is negative 50 meters. Why negative 50? Because it's going down. And the acceleration is for the 100th time, negative 9.8 meters per second squared. And we are asked to find the time. So this object has just dropped from 50 meters high. Find the time. Same equation. Is that the 4th time we're using that? E naught t plus 1/2 at squared. All right. And then substitute carefully. You get negative 50 is equal to that term. Again, this term is 0. So it's 1/2 times negative 9.8 times t squared. And then simplify that, you get negative 4.9 t squared there. Divide both sides by negative 4.9. Yep. And then you cancel out from that side, so that's only t squared. And then once you get the value of t squared, take the square root. Remember, negative by negative is positive. So you get a positive number. Well, time can never be negative, of course. So you get 3.2 seconds. That's the deal. So that's how we work out these problems. So I hope this made some sense to you. And if you still have questions, you can always write to me. You can always ask me on YouTube or in the class, and I always make it a point to respond. So see you on the next video. Thank you.